Howdy. Today we're talking about multiplication and division inequalities, so get your name, date, and title at the top, please. And we just need to know that weird things happen with multiplication and division inequalities. So what I'm going to try and do here is demonstrate this a little bit. For example, let's see. We're used to doing the same things to both sides of an inequality. And here I have four inequalities that are absolutely true. 6 is greater than 3, 12 is greater than or equal to negative 11, 4 is less than 14, and negative 13 is less than or equal to 9. I hope you all agree. Now let's say, what if we're going to multiply them? Let's multiply them by the positive number 2. Let's multiply both sides of this first inequality by 2. I would get 12 is greater than 6. Is that still true? Yes, it is. I'm going to change the second one. Still true. Now, let's think about this one. Let's think about division. What if I divide both sides by the same positive number? What if I divide both these by 2? Well, we get 6, and if I divide negative 10 by 2, I get negative 5. Is 6 greater than or equal to negative 5? Yes, still all good. Now, let's think about what if I multiply by a negative number. So let's multiply both the sides of this third inequality by negative 2. We get negative 8 is less than or equal to negative 28. Negative 8 is less than or equal to. That's not true. Let's cancel that one. Okay, multiplying by negative 2 didn't work. I'm going to change this one too. Let's try dividing both of these sides by negative 3. So if we divide negative 18 by negative 3, we get a positive 6. Divide this by negative 3, get negative 3. So 6 is less than or equal to negative 3. That's not true either. So let's cancel out that last one. It didn't work when we divided by a negative number either. I don't know. That was weird. Let's just move on to some notes, shall we? Notes. Solving one-step inequalities is nearly the same process as solving one-step equations. It's almost the exact same thing. We saw that yesterday. The only thing is we have a different little symbol, and we plot them on a graph because there's an infinite number of solutions instead of just one. But wait, there's more, because it's not the exact same thing. Why not? Because whenever we multiply or divide both sides of an inequality by a negative number, the inequality sign has to flip. It has to flip. And so there are some good ways to explain this. I am going to try and say, if you're multiplying or dividing both sides of an inequality, it doesn't make sense to have the inequality face the same way. For example, what is the opposite of the temperature being greater than 50 degrees? It's not the temperature being greater than negative 50 degrees. We have to change the sign as well to get the opposite. So the opposite of the temperature being greater than 50 degrees is the temperature being less than, or switch the sign, negative 50 degrees, and because we multiplied both sides by negative 1, or the opposite of the temperature. That was a bad example. I'm sorry. There's a rule. We got to follow it. Here we go. We're looking at our examples. This is to solve and to graph. So I'm going to think to myself, well, this is exactly the same process almost as solving one-step equations, but it's an inequality. So J is being divided by negative 8. How do I undo division by negative 8? Well, that's by multiplying by negative 8. So this will cancel over here. We're multiplying both sides by a negative, so I know that because of our new rule, I need to flip that sign. Now J is greater than 13 times negative 8. I know that'll be a negative answer because we multiplied both sides by a negative. 8 times 13, well, I know that 8 times 12 is 96. And we don't just have 12 groups of 8, we have 13 groups of 8. So 96 and 8 more would be negative 104. So there we go. J is greater than negative 104. So we're going to draw our inequality. We're going to graph it. We're focused on negative 104. We know that J is going to be greater than negative 104, but not equal to. So open bar or open circle. That's not a bar. And I also like to include these two other values to make sure that this makes sense. Let's include a lower value, that'd be negative 103, lower value, a lower negative or a greater value, and a smaller, more negative, a less value on the less side, the left, is negative 105. Number 2, 5m is greater than 430. So we're going to undo multiplication after I draw the scales of injustice by dividing both sides by 5, and we'll get m. We divided both sides, but it was by a positive, so the sign doesn't change. So 430 divided by 5. Okay, well, let me think of a way to do this mentally. Well, I know that 10 goes into 430 43 times. And 5 is half as big, so it would need twice as many. So not just 43, but it would have to be 86 times. So 86 times 5 would be 430. 430 divided by 5 is 86. M has to be greater than 86. This one's easier to graph. We're just dealing on the positive side. 87 is one larger. 85 is one smaller. M is greater than but not equal to. So again, we're not going to fill that bad boy in. But we are going to shade all the values that could be true for J in the first one. Shade all the values that could be true for M in the second. Last one, draw the scales of injustice. We're going to divide both sides again to undo multiplication. Dividing both sides by a negative, though, will flip my sign. Instead of G being less than or equal to, G is now greater than or equal to. It's on the bigger side. It's getting eaten, as a lot of people like to think of it. This is going to be a positive answer, and I can actually do this one mentally, too. I have a feeling that it's going to come out evenly as an integer. So I'm going to say, well, I know 12 times 12, 12 groups of 12 would be 144. 13 groups of 12 would then be 144 plus 12 would be 156. 14 groups of 12 would be 168. And it's a positive answer because we divided a negative and a negative. Again, we're going to plot this answer on a number line. The number we're focused on is 14. 1 less is 13. 1 more is 15. And what we need to know here is we're going to fill in the circle. But the last thing we need to know is that, yes, this is the less than or equal to sign. But if 14 is less than or equal to G, then G is greater than or equal to 14. 14 is on the short end. G is greater. So you can rewrite that like I just did, or you can read it from right to left. But you just got to read that sign differently. G is greater than or equal to 14. Even though that's the less than or equal to sign, the greater side is towards G. All right, there are your examples. Hopefully they made sense. I'll give you a better explanation with a visual of the number line about why this makes sense. But the rule is important for now. We'll talk about it more before we do our assignment. But just give these 3 a shot with your notes. These 2. Negative 16m is greater than or equal to negative 336. And number 2, negative 4 is greater than k over 17. So solve those and plot them or graph them for me. Thank you so much.